Welcome to Table Talks. Today still we are moving on with coordinate geometry as usual as far as P425/1 is concerned, that is pure mathematics. So, and our question was the points A to 1, P alpha beta and B1 2 lie in the same plane. That means they lie in the same line, straight line. PA meets the x-axis at the point y at the point h0, and PB meets the y-axis at the point 0k. Find the value of h and k in terms of alpha and beta. We'll go with the solution. Consider the on a Cartesian plane, which has this is a Cartesian plane, and this is the x-axis, and this is the y-axis. So you can see that we have got lines which are meeting the x-axis and the y-axis. You can see PA meets the x-axis. This is the x-axis. It means our point A is on this one. You can even do like this. If it is, this is the x-axis, it is meeting it somewhere there. And they said it is meeting at the point h0. This is my, and they say the PB meets the y-axis. We start with the x-axis. It is meeting it at point h0. Can you call this point maybe is R? R is h0. And again I've said there is another point here which we want to know. This is point A. A is already 2, 1. This is A 2, 1. Again I've said PB meets the y-axis. Can say this is point B and is meeting at the point 0k. I can call maybe this is this is 0k. I can call this point B maybe S, and point B somewhere here, and point B is given as 1, 2. So this is point B where they are meeting, because they said on the same plane, which I'm calling alpha beta. Now, since they are straight lines and in the same axis, it means gradient of SB is the same as gradient of SB. I can say for gradient SB, can say gradient SB equals, since they are the same straight line, what we looked at, equals gradient BP or PB N BP. So and we said gradient is changing y over changing x. So we go with this. It becomes with gradient SB to be changing y, which is 2 minus k all over 1 minus 0, which is equal to gradient BP, which will be changing y, which is beta minus 2, all over alpha minus 1. So go ahead and we try to cross multiply. So this is the same as 2 minus k out of 1, which is equal to beta minus 2 over alpha minus 1. So we go ahead. Our interest is to make h and k. For this case, I'm going to make k the subject. We cross multiply. It becomes 2 minus k into alpha minus 1, which is equal to beta minus 2. Can we try to open up the brackets? 2 times alpha, we are getting 2 into alpha minus 1 minus k into alpha minus 1, which is equal to beta minus 2. Can we open 2 times alpha? We are getting 2 alpha minus 2 minus alpha k plus a k, which is equal to beta minus 2. So what we're going to do, 2 and 2 disappears. We remain with 2 alpha minus alpha k plus k equals beta only, because the negative and negative 2 disappears. So can we guide, do you take this one the other side? I'm remaining with k minus alpha k, which is equal to beta minus 2 alpha. So what is common here is a k. I remain with 1 minus alpha, which is equal to beta minus 2 alpha. So can we make k alone? K alone equals beta minus 2 alpha all over 1 minus alpha. So this is the expression for k. Now we want to go and find also the expression for h. So we are going to also consider this line. We also say that gradient PA is the same as gradient AR. So we are going to use the same scenario and we are using the same way, the gradient ratio. So after writing that expression for k, we are free to go ahead and look for the expression for the value of h. We are going to say gradient PA, you can say still using gradient ratio, you can say using gradient ratio or using gradient formula. So we are saying gradient PA is the same as gradient AR, is the same as gradient AR. So what is the gradient of PA? PA, we're going to have change in y, which is 1 minus beta, 1 minus beta, 1 minus beta, so 1 minus beta, all over 1 minus beta, all over 2 minus alpha, which is equal to, we are looking at the change in AR, 1 minus 0, 1 minus 0 all over 2 minus h. So go ahead and we reduce, this is 1 minus beta all over 2 minus alpha, which is 1 over 2 minus h. Cross multiply, we are getting 1 minus beta into 2 minus h, which is equal to 2 minus alpha. Can we open? It's going to be 1 into 2 minus h minus beta into 2 minus h, which is 2 minus alpha. 1 times 2, we are getting a 2 minus h minus 2 beta plus h beta equals 2 minus alpha. So can we try now to bring h close? And what happens with 2 and 2 disappears. So we are remaining with h beta minus 2 minus h minus 2 beta equals a negative alpha. We take that one there, we are getting h beta minus h equals 2 beta minus alpha. What is common here is a h into beta minus 1 equals 2 beta minus alpha. What is the meaning? We are getting h now, making h alone equals 2 beta minus alpha all over beta minus 1. So this is the expression of h in terms of alpha and beta.